My name is Brandon Horton, and I am in the August 2010 physics class, and this is my podcast on magnetism and electricity. I'll mainly focus on the magnetism aspect, but it doesn't exist without electricity, so I'll have to put a little bit of that in there. Magnetism is actually electricity that moves in one direction. More specifically, the electrons. Every spinning electron is actually a tiny magnet, and when you have a pair of spinning electrons that move in the same direction, it creates a stronger magnet, and if you have like four of them, then it'll be stronger, and so on and so forth. So, the more electrons you have moving in one direction, the stronger your magnet will be. When this happens in iron, it creates a magnet. And that also explains why every piece of iron isn't a magnet. The domains in ordinary iron aren't aligned, moving in the same direction. This picture can better illustrate this. The more electrons that move in the same direction, the stronger the magnet will be. As you can also see from the picture, this creates a north and south pole. The directions that the electrons move toward is called the north pole of the magnet, and the directions they move away from is called the south pole of the magnet. This will make one side positively charged and the other side negatively charged. The like charges will repel, positive and positive repel, and negative repel, and the opposite charges will attract, positive against negative. If you cut the magnet in half, you won't have a north pole on one and a south pole on the other. You'll just have two magnets that have a north pole and a south pole. I figured the best way to demonstrate these principles of magnetism is with magnets. So, this right here acts as one magnetic rod, which I already stated to you has a north and a south pole. I also told you that if you cut one of these in half, you're not going to get a north and south pole on the two separate magnets. Each individual magnet is going to have a north and south pole itself, as if it were just this one, just smaller, if you get what I'm saying, to put it simply. So I can't cut this in half because it's iron and it's pretty hard to do. So I got these already cut that will act as one or will go apart. So I'm going to break it apart like it was cut and show you that each one of these has a north and south pole, which means a positive and negative. So if I can get these to repel each other and also attract each other, then I can prove that if you cut it in half, you'll have both of the poles and both charges. Let's not put it. There you go. Pretty strong magnets. They did attract. Now, that proves that each one of these has at least one pole. But no magnet is known to exist that has only one pole. So let's prove that it has the other pole. Now, I'm going to try to get these to repel. So let me try to see if I can push this magnet. Put my hand here so I'm not touching it. And let's try to push this magnet. And I'm pushing this magnet across the table. And of course, it flipped the magnet and came back because that force is so strong that they just want to attract. From attracting to rolling it along, it's pretty fun to see. Just push it along because it has a magnetic field around it. So all around this magnet, there's a magnetic field with that force, because that force is so strong, it's either pushing or attracting things depending on their charges everywhere around it. So something cool that you can do like this is, you see right here, is connecting, because these are opposite charges and opposites attract. I'm sure you heard the phrase before. So if I put this on the opposite end, and you can't feel this because you're not touching it, but I am touching it. You can just take my word for it. It's kind of hard to push down because there's a force here. So I'm pushing down, and it's the same force, which means that it's repelling. So I'm holding it down, and if I let go, it will repel this one on top away because I have it on two like ends. So I'll go and I'll let go, and it flew away just like that. Let me try to show you that again. It flew away. just repelled it and pushed it away. So hopefully you will understand that this is what causes magnets. The electrons flowing through this from one side to the other side causes a magnetic field around these magnets where the like charges repel and the opposite charges attract to each other. And every time you cut a magnet in half, no matter how many times, it will always end up with a north and a south pole and a positive and negative in each individual magnet. So I could take this, and starting from any one of these magnets, I could take this and push it and grab each other magnet. See, if it's on the opposite side repelling, it will flip and go to its like side. I hope you enjoyed my demonstration on magnetism and electricity, which causes the magnets, so which I hope you understand now. And thank you for watching.